Now, armed with that, we can now go and talk about what determines the slope of indifference curves and the shape of indifference curves. So now we can go and talk about the slope and shape of indifference curves. Okay? Now, let's think sort of intuitively. Let's think intuitively. I'm going to put this up now. Everybody get this? Okay. Let's think intuitively about what the slope and shape of a difference curve means. What it means is basically the slope of an indifference curve is the rate at which you're willing to give up one good to get another. Okay? As you move along an indifference curve, so let's take the indifference curve. Let's go back to figure 4.1b. Okay? There's this indifference curve that's got A and B on it. As I move downward on that difference curve from A to B, I'm moving from 2 pizzas in one movie to 1 pizza in 2 movies. So we say in economics, I'm effectively giving up pizza to get movies. Now, in reality, of course, you aren't. You don't pay for the movie with a pizza. This isn't a barter economy. Okay? But in practice, you do that because what we're going to show next time is you have a limited amount of money. And how you allocate that, if you allocate more of that money to movies, you have less to allocate to pizza, and vice versa. So we talk about trading off pizza for movies. We don't literally mean making trades of that sort. We mean getting more movies means you have less resources to spend on pizza. So essentially what this indifference curve tells you is the rate at which you're willing to trade off pizzas to get movies. Okay? And so we are going to define the marginal rate of substitution, a key concept we'll use throughout this section, throughout the course. The marginal rate of substitution we're going to define as minus delta p over delta m that comes from the indifference curve, the slope of the indifference curve. That's the rate at which you're willing to trade the y-axis for the x-axis. The rate at which you're willing to trade, okay, pizza for movies. Okay? And the idea here is, once again, you're indifferent between all points on this curve. Therefore, you're happily making this trade of pizza for movies as you move along this curve. Okay? So to bring this home, let's look at figure 4.6. Okay, figure 4.6 is showing us an indifference curve. Let's work on figure 4.6 for a couple minutes. Here's an indifference curve. Once again, this indifference curve, I'm not saying this is the truth for everyone, but it's the indifference curve generated by this utility function. We've assumed these are people's, this is the right mathematical representation of preferences, okay? And this is the indifference curve generated by that utility function. So there's 3 points. So for example, people are indifferent between 4 pizzas in one movie, 2 pizzas in 2 movies, or 1 pizza in 4 movies. Now, you may say that doesn't work for me, that doesn't feel right to me, but it's not crazy to think that that could be someone's preferences, and it is what this function would generate. Now, let's think about what the marginal rate of substitution is. The marginal rate of substitution says, as I move from 4 pizzas in 1 movie to 2 pizzas in 2 movies, that means I'm giving up 2 pizzas and gaining 1 movie. And yet I'm indifferent between that. That means along that segment of the indifference curve, my marginal rate of substitution is -2. I'm willing to give up 2 pizzas to get 1 movie. Now I'm at 2 movies and 2 pizzas. Now someone says, well, gee, you want 2 more movies? How much pizza are you willing to give up? Well, now you say, well, look, before I had tons of pizza, and I really wanted to see both Black Mass and Everest. So I was happy to give up a couple of pizzas to see a second movie. Now I've kind of seen Black Mass and Everest. I don't even know what the 3rd movie I'm going to see is. I only got 2 pizzas, so I'm not totally full. Now I'm not so willing to give up pizza to see movies. Indeed, if you want me to see 4 movies, I'm only give up 1 pizza to get that. Okay? And so my marginal rate of substitution now has become -0.5. You're giving up, I'm defining the concepts, you're giving up, delta P is, it's just a definitional thing. So what we're saying is, I'm defining both these terms as positive. You don't have negative pizzas. What I'm saying is, there's 2 pizzas. You give up 2 pizzas. to get one movie. Those are both positive constants, pizza and movies. To turn it into the negative number, which corresponds to slope, I put the negative in front of it. That's another way to think of it. Okay? So basically what you have is you have this margin rate of substitution is negative delta P over delta M. You're giving up 2 pizzas to get 1 movie. And generally what you find is that this is diminishing. The margin rate of substitution is diminishing, and that's because of diminishing margin utility. So because margin utility diminishes, because each additional movie is worth less to you than the one before, and each additional pizza is worth less to you than the one before, which is, we said, a very sensible assumption, that generates the fact that indifference curves are downward sloping. Okay, so here's the key thing. Why indifference curves are downward sloping? We showed before they couldn't be upward sloping because it violates more and better. Now we can see how they're downward sloping, and how we can go further now, and we can say that the slope is actually decreasing as you go along because of this principle of diminishing margin utility. So further, so what we say is that the margin rate of substitution can be defined as the negative of the margin utility of movies over the margin utility of pizza. Okay, so the margin rate of substitution equals minus the margin utility of movies over the margin utility of pizzas. So basically the marginal rate of substitution is telling you, what is it telling you intuitively? It's telling you how the margin utility evolves, how your preferences evolve as you move down the indifference curve. Now what's interesting here is you might say, well gee, MRS was about delta P over delta M, but I wrote MUM over MUP. Why'd that flip? It flipped because remember, margin utilities are negative functions of quantities. Okay? So as you have more pizza, you have a lower margin utility of pizza. As you have more movies, you have a lower margin utility of movies. Okay? So the point is, as you're moving down this indifference curve, once again, let's look at the figure. As you're moving down this indifference curve, you are getting more and more movies and less pizzas. That's making your margin utility of movies fall, and your margin utility of pizzas rise. So the slope is falling, okay, as you move along this indifference curve. All right? And so that's why you get indifference curves that are convex to the origin. They have these diminishing utility functions. Imagine for a second, let's go to figure 4.7. Imagine for a second difference curves didn't look like that. Imagine difference curves were concave to the origin. Okay? They still slope down, but instead of being convex to the origin, they're concave to the origin. Think about what that would imply. That would imply that when I start with 1 pizza and 4 pizzas and 1 movie, I'm willing to give up 1 pizza to get 1 movie. Not unreasonable. So that I have only to have 2 movies and 3 pizzas. Now I would be willing to give up 2 pizzas to get the next movie. That's implausible. Why? Why is it implausible that having given up 1 pizza to get the first movie, I'm willing to give up 2 pizzas to get the second movie? Why is that implausible? Yeah.
Diminishing marginal utility.
What? Explaining.
Since we're not as happy, the second one isn't going to make us quite as happy as the first one, why would we give up more pizza?
Exactly. So if I was only willing to give up 1 pizza to eat black mass, why would I give up 2 pizzas to see some movie I don't even know what it's called? Okay? Clearly, that violates diminishing margin utility to have a concave to the origin indifference curve. Because that would imply I'd be willing to give up more pizzas the higher the number of movies I have is, and that violates diminishing margin utility. Okay? So basically, this would imply I prefer my third choice to my second choice. And that violates diminishing margin utility. Now remember, I still want to see the third movie, even though I don't know what it's called. I still want to see the third movie because more is better. But I don't want to see it nearly as much as I want to see the second movie. And I don't want to see the second one nearly as much as I want to see the first one. I'm really excited to see the first one. Okay? And so diminishing margin utility generates these convex to the origin difference curves. So for the rest of the course, we'll be drawing these convex to the origin, or at least non-concave. I'm not saying they won't be linear, but non-concave to the origin indifference curves. Okay? And that is simply because of diminishing margin utility yielding these MRSs that are everywhere diminishing as you move along the indifference curve. Okay? Questions about that?